Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from section 4-2 in the SavvasRealize Algebra 2 textbook. So the goal of this example is to use a rational function model. So they're giving us an equation that explains a real-world situation, and I'm showing how to use it. So this says that the cost of removing a pollutant is modeled by this function, where f of p is the cost in millions of dollars of removing p% of the pollutant. Alright, so p is the pollutant, and f of p, or our y value, is the cost. And so what they want us to do is they want us to figure out if I have a cost, or the usual y value, of 78.3 million, how much of the pollutant is going to be gone? So what I'm actually going to do is I'm going to rely on Desmos, all right, to help me with this problem. And so I'm going to take this function and I'm going to plot it on Desmos. Now, I don't know if Desmos would accept me to use the letter P, so I'm just replacing the letter P with an X. I know that might be frowned upon in polite society, but there it is. So here is the function itself. I feel like something's off. I'm just checking it out, making sure I typed everything in right. When they graphed it, they had a curve. I don't have a curve. Oh, it's because I need to zoom out. There we go. Right, it makes sense to have a curve. So just double check yourself. Make sure, if you're in a section that looks really linear, that some of your numbers are going to be a little wild. Now, P is a percentage, right? It's the amount of pollution. So it's not like you can remove 160% of the junk from the air. So I'm going to focus mostly from 0 to 100 on my graph. So if I go back here, we're trying to figure it out for $78.3 million. So our y value would be 78.3 million. Oops. So when I go to Desmos, what I'm going to do is I'm actually going to put the 78.3 in as a line, because I'm looking for how much of this P will be available at that point. So all that I need is that point of intersection that you see right there. So what I'm doing is I'm just taking a snippet so that I can plop this bad boy on my slideshow for our viewers who look at it later. There we go. So what this is telling us is that for that $78.3 million, I can remove 90% of the pollution. And so that's what I'm actually going to type out here, because word problems like word solutions. So I can remove 90% of the pollutant with $78.3 million. And so again, that just came from looking for that intersection. So this seemed like a kind of daunting problem at first, but then once I thought about it and what each variable meant, it made it a lot easier. So now they're changing it and they say there's new techniques for the function. And so they're asking us to do the same thing but now with a new function. And so we're going to have $50 million. So I'm going to change this to a 50. And our new equation has 3.2 P, which I'm calling X to make Desmos happy. Alright, and so here's our new graph, and here's our new point of intersection. Alright, so now that they have those new techniques, now we can analyze how much pollutant will be in the air. So if I zoom in my graph, try to make it look a little better. This point right here, again, is the $50 million. And so you have 93.966. Alright, I'm probably going to call that 94%. You can remove approximately 94% of the pollutants with $50 million. Alrighty, so there we have it. That is using our rational function model. Until next time.